Hello guys and welcome to Engineering Key Tutorials. So in this video I'm going to solve this static problem about this vertical building with diagonal bracing or this vertical truss. As you can see we have this vertical truss. This is the horizontal members and the diagonal members and vertical members, and here we have roller support and hinged one, and here we have 3 kilonewton at every joint. Here we have 1 kilonewton at every joint, and the label of the joint A, B, C, D, E, F, G, H. In this kind of problem he asking about uh, force in member CE. If asking you about one member or two members, you don't have to use the join method. If asking you about all members or to find the forces in the all members, you have to find you have to solve with the joint method. But here, the best way to solve this problem, you have to use the section method. Okay. Also here, in the section method, we have two way to solve this problem. First way, you have to find the reactions at G and H, and um, for example, take the section here and solve the below part of the problem. I preferred if you can solve without find any reaction, or using the upper part or the upper zone here, it is will be great. Why? You can save your time in the exam and solve it very quick. So the best way to take the section here, because here the required force here in member CE, so you take the section here and passing through this diagonal section and finally through this vertical section. So this is the best section you can take in the problem. If you look, you can take this upper section or upper zone or this lower zone. I prefer to take this upper zone. Why? Because you don't have to find the reactions. Okay, if you take this upper zone here, let's draw it quickly. Here, this, and here the required force, maybe tension, maybe compression. Let's assume tension, and this is the diagonal force in this diagonal member, and this is the vertical. In the section method, as you know, you can take summation of force in x direction equals 0, or summation forces in y direction equals 0, or summation the moment at the joint equals 0. Here, the best way to find this required force, to take the moment around this D joint. Why? If you take the moment around this D joint, you can cancel this force and this force and only solve with the required force one equation with one unknown, and you can solve it very easy. So here we have 3 kilonewton. Here we have 1 kilonewton. Here we have 3 kilonewton, and finally here we have 1 kilonewton. You don't have to use this one and this one because there are no lever arm for these forces around the point D. Only you have to use the 3 kilonewton and 1 kilonewton and the required force F. Let's assume summation moment around the D equals 0, and let's assume the counter clockwise is positive. Okay, as you can see here, this distance, this horizontal distance is 12 meter. So 12 times F is, which is the required force, equals to 3 kilonewton times the vertical distance, which is 9 meter, plus 1 kilonewton times also 9 meter. So F equals 3 times 9 plus 1 times 9 divided by 12. So the force equals to, so 27 plus 9 divided by 12 equals 3. And it is positive, means the assumed direction is right. So it is 3 kilonewton tension. Also guys, in this problem, if asking you about the reactions about G and H, you don't have to uh, solve the reaction uh, due to the ordinary method, take the moment around one joint or around one unknown, and find the other, and take summation forces in y direction. No, it takes long time, and you have to solve it in easiest way using couple approach. How it work, this couple approach? As you can see here, we have the horizontal forces only. The horizontal forces 3 and 1, 3 and 1, 3 and 1. This you can deal with it as 4 kilonewton, 4 kilonewton, 4 kilonewton. This forces makes torque about this joint. So you can think about couple makes this torque in equilibrium. So you have to find this torque, 3 plus 1 times 27 plus 3 plus 1 times 18 plus 3 plus 1 times 9, and get this torque about this, around this H point or H joint. And we need, after that, find the couple makes this torque or makes this moment in equilibrium. How? Like this. Here we have 3 plus 1, 4 times 999 equals 27, plus 4 times 18 plus 4 times plus 4 times 9 equals 216, and divide this value to 12 to find the required couple makes the structure in equilibrium. So answer divided by 12 equals 18. So if this torque due to these forces in clockwise, you have to make anti-clockwise torque to make this structure in equilibrium. So this here we have in this direction and this force in this direction to make this torque anti-clockwise or counterclockwise to make the structure in equilibrium. Here 18 and here 18 kilonewton. This is due to vertical reactions. In the horizontal reactions here, this is roller, so there are no there is no horizontal reaction at this joint, and here this is only support takes these horizontal reactions. Summation forces in x direction equals 0, so 3 3 3 1 1 1 3 times 3 9 plus 3 equals 12. So the reaction is 12 kilonewton in the opposite direction of the forces, so is in this direction. It is in this direction.